Alright, so since I'm not in school today, we'll be talking about this using the video, and then you'll get some new assignments to work on. So we'll go over the problems from Friday. Now, review from Thursday, what we discerned from the lab. For a series circuit, the total current is the same throughout, so the current through any resistor is equal to the total current. The voltage is split up amongst all of the resistors in there, so the VT equals the voltage through the first resistor, voltage across the second, and the voltage across the third. The total resistance for a series circuit is just added up. Resistance of the first, resistance of the second, resistance of the third. For a parallel circuit, it's a little different. The current is split up, so the total current is equal to the current through the first resistor, plus the second, plus the third. The voltage, however, is the same for each path. So the total voltage is equal to the voltage through the first path, equal to the second, equal to the third. And then we see our fun equation for calculating the total resistance, which we'll have a little practice with in the problems. Now, on the Circus worksheet, problem 1A, you're told to set up a circuit with battery with one light bulb, complete so the light bulb lights up. Then add a second bulb and note the difference in brightness. Now, of course, you should have noticed that the brightness went down. And the reason for this is that as we add a second light bulb, the total resistance goes up. If the total resistance goes up, the voltage stays the same, the current goes down. And it's really the current that we're looking at is what's causing the brightness. 1B, what do you think will happen to the brightness of the first light bulb at a third? Hopefully you thought that it was going to go down even more. And 1C should have saw the brightness decrease. And in a series circuit, as we add more light bulbs into it, without changing the voltage, the brightness will go down because the current will go down because the total resistance is going up. Now 1D, we're going to do this now with the parallel light bulb. And hopefully what you saw was that the brightness didn't change. And the reason for this is, of course, that the current really depends upon, well, only one thing. The current is equal to the voltage divided by the resistance. Now, in a parallel circuit, all the voltages are the same, no matter how many paths we add to it. And so the current just depends on each path. And so we could add a lot of light bulbs in there. They would all have the same current flowing through them. Now, what will this do to the battery? It'll just deplete it much more quickly because it is using up more energy. Because if the current stays the same, and we just add more and more paths for the current to flow through, we're going to lose energy more quickly. All right, question 2. And yes, I noticed that there are 2 question 2s. I didn't notice it until after I had it copied. So the first question 2, what type of meter is being used here? Well, of course, we can see that this is part of the circuit, so this is an ammeter. An ammeter. So if it was just across 2 points, not part of the circuit, it would be a voltmeter, but this is an ammeter measuring current. Now, total resistance in the following circuit. Well, this one is simple. The total resistance is equal to the first resistance plus the second. So it's 10 ohms plus 5 ohms. And so it's a simple little 15 ohms. So in a series circuit, we just add them up. How do you find the total resistance in a series circuit with 3 resistors? Well, in a series circuit, and this just comes straight from our equation, we just add them up. In a parallel circuit, that's when we do the inverse rule. Now we'll get a little practice with this because although it should be very simple to do, a lot of people do make mistakes when they get to the last part. So we'll do a little practice with that. Question 4. Find the total resistance and current in the following circuit if the power source has a potential difference of 12 volts. So our total voltage is 12 volts. Our total resistance in this circuit, because it's a series circuit, we just add them up. So 2 ohms plus 6 ohms plus 4 ohms. Nice, simple 12 ohms. So there's one of our answers, the total resistance. Now the total current is equal to the total voltage divided by the total resistance. So total voltage here is 12 volts. The total resistance is 12 ohms. Nice simple math. How nice does this work out? And our answer is 1 amp. Now because this is a series circuit, this is also the current through each resistor. All right, question number 5. Find the total resistance and current in the following circuit if the power source has a potential difference of 12 volts. So that's our total voltage. total resistance in this one's a little bit different. So 1 over the total is equal to 1 over the first, which is 1 over 6 ohms, plus 1 over 12 ohms, plus 1 over 6 ohms. Now, we can do this two ways. One, we can just plug this into our calculator, which you can do, but just remember that it's 1 over the total is equal to that, so you do have to flip them at the end. However, I like to do this since I easily see common denominators. I'm going to do this by just adding them out. So 6s and 12s, 6 goes into 12 twice, so 1/6 becomes 2/12, plus 1/12, plus another 2/12. So my 1 over my total is equal to 2 plus 1 plus 2 is 5, so 5/12. Now this is 1 over the total, so I need to flip both sides, so I get total over 1 is equal to 12 over 5, or I can write out that the total resistance is equal to 2.4 ohms. And like I said before on Thursday, notice that the total resistance is less than any one of the resistances involved. So 2.4 is less than 6, so that makes sense. Now we need to find the total current. So the total current here is equal to total voltage over total resistance. And so it's our 12 volts divided by 2.4 ohms, which is equal to 5 amps. Now, just a quick note on this. If you did this in your calculator, you would have got 1 over total is equal to 5/12. And if you just put your answer as 5/12, you'd be wrong. You have to flip it. So you do 1 divided by 5/12, and that would be your answer. All right, question number 6. In a series circuit, R1 has a resistance of 18 ohms and a current of 2 amps flows through it. What is the total potential difference if R2 and R3 have resistances of 10 ohms each? Now, since this is a series circuit, the current through one part is equal to the current through the whole system. So the total current for this system is 2 amps. To find the total voltage, I need to take the total resistance times the total current, and I need the total resistance. Well, series circuit, that's easy. I just add them up. So 18 ohms plus 10 ohms. 10 ohms plus 10 ohms. That's a nice even 38 ohms. So if I go back up to here, 38 ohms times 2 amps gives me a total voltage of 76 volts, and that is our answer. And again, it's all because of this. The current through one part of a series circuit is equal to the current through the whole thing. So total current is equal to current through the first resistor. Question 7, in a parallel circuit, there are 3 resistors of equal size, 6 ohms. What is total current and potential difference if one resistor has a current of 10 amps? Now I'm just going to draw this out just real quickly, just so I can visualize this. And of course my drawing's not going to be too great, but that's alright, it's a sketch. So 6 ohms each, so 6 ohms, ohms. And this one resistor has a current of 10 amps. Well, they're equal size resistances, so each one has a current of 10 amps. In a parallel circuit, if there are equal resistances, there will be equal current. So each side must have 10 amps. Now, what that actually does for us then is that the total current then is equal to 10 amps plus 10 amps plus 10 amps. So the current through each part, 30 amps. And I'll show you a different way of doing that in a second. All right, so the total voltage. Well, we know in a parallel circuit, the total voltage is equal to the voltage across each path. So in this case, my total voltage is equal to the voltage across the first, and that is equal to the current through the first times the resistance through the first. So current of 10 amps times the resistance of 6 ohms, that gives me 60 volts. And that's my total voltage. Now, I could have calculated my total resistance, which is 1 over 6 plus 1 over 6 plus 1 over 6, which equals 3 over 6. Flip that. 6 over 3 gives me a total resistance of 2. Well, total resistance of 2 and a voltage of 60 volts would give me a total current of 30 amps. So I could have done this a couple different ways. Question number 8. What will the voltmeter read in the following circuit? Now, in a series circuit, the voltage on each part is different. So I know some of you want to say 12 volts right away, but that'd be only true if this was a parallel circuit. This is a series circuit. So in order to solve this, we just have to take a couple steps. So let's call that third resistor, the one we're looking for, is V3. So that's what I'm trying to find here. Now I know to find, sorry, my pen keeps slipping. To find my third voltage, I need to know my third current and my third resistance. Now, since this is a series circuit, the total current is equal through the current through each part. So, my total current here is equal to 12 volts over 10 amps. 10 ohms. Is equal to the total voltage divided by total resistance, which is a nice equal 1.2 amps. Now that 1.2 amps is flowing through each part. So again, my total resistance here is just 4 plus 4 plus 2. So that's where I got my 10 ohms. Total voltage is 12 volts. And so you easily see that. So my total current is 1.2 amps, which is also equal to the current flowing through the third part. To find the voltage for the third part, I just need my current and my resistance. So 1.2 amps times a resistance of 4 ohms, which means the voltage for the third resistor is 4.8 volts. And that is it. Now this one part, the last problem had a couple parts to it. You just had to write what you wanted to know. We wanted to know the third voltage. And again, that third voltage, I need to know the current and the resistance. Well, I already knew the resistance. I didn't know the current. But since it was a series circuit, I know that the total current is equal to the current through every part. So if I find the total current, I found the current through the third part. And then I can find the third voltage. So hopefully these problems help you understand Ohm's law a little bit better in series and parallel. Just to make sure we fully understand this, here's your homework. Work on these problems during class today. Try getting them done for tomorrow so that we can go over them. If you still need a little bit of work time on Tuesday, that is okay. We will finish them then. But it's series and parallel, and then a couple of conceptual questions. So if you have any questions, write them down. We'll go over all this on Tuesday. So that is it. See you tomorrow.